Welcome to this video on the 7 keys to mesmerizing Milky Way photography. We're going to get started by learning how to view the Milky Way at night. How do you view the Milky Way at night? Well, that might sound like an odd question because, as you probably know, we're in the Milky Way, so all you really need to do is look up. But it's not as simple as that. There's actually 3 things you need to consider if you want to have clear pictures of the Milky Way. Number 1 is the weather. If it's a cloudy night, you're not going to see clear images of the stars. That kind of goes without saying. But there's been times when I've gone out to shoot the Milky Way, just when I was first starting with photography. I thought, okay, good, there's no moon in the sky, I'll be able to see the Milky Way. And then I realized the reason there's no moon is because a cloud is blocking it. So you need to make sure you have clear weather. That's why it's often best to try and do this during summer months. And number 2, as I just mentioned, you need to consider the moon. So the moon goes in phases. It comes up and down just like how the tides change. It changes by an hour every single day. So you need to consider, where is the moon going to be? If the moon is out in the sky, well, believe it or not, that acts like a big light like this, and it's going to blow out the stars and you won't see hardly any at all. But there's an app for that. So an app I like to use is called Deluxe Moon, and it looks like this. And by moving, depending on the date, you'll be able to see when you have a new moon and how long the moon is going to be in the sky for. So I can see that on February the 18th, 2018, it's just past a new moon. The moon is going to rise at 8 in the morning and it's going to set at about 8 at night. So I know from 8 o'clock at night, there's not going to be a moon in the sky, which is perfect. It means that it's not going to get in my photos at all and it's not going to blot out the stars. And the third thing you need to consider is the sun. So obviously we're not going to be shooting the Milky Way during the day, but did you know that it's not as simple as the sun setting and the sun rising? It actually goes through a few phases. And an app I like to use for this is called Sol, S-O-L, and it looks like this. And as you can see, it's going to show me different times of night. So we have daytime, afternoon, golden hour, which is the hour before the sun sets, civil dusk, nautical dusk, and astronomical dusk. So astronomical dusk today is about an hour and 40 minutes after the sun sets, but you won't see clear photos of the stars until after astronomical dusk has finished. You need to have total darkness, full darkness. And for that to work, you need to make sure that you check your app or whatever website that you like to use and make sure that the sun is not going to be blotting out the stars at all. So you need to consider the weather, whether the moon is going to be out, and on top of that, where the sun's going to be in the sky. And these things can often overlap for just very small windows. When I was shooting Yosemite Valley, I had just 45 minutes. I think it was about 4 o'clock in the morning. The moon had just set and I had 45 minutes until astronomical dawn, where the sun, even though it is hours away from actually coming over the horizon, it was going to start blotting out the stars. So with that in mind, I knew that I had to get to location, and I actually went to a couple different locations because I could plan for this. I could use the apps and know exactly where I needed to be. I knew that I had 45 minutes from the moon setting to astronomical dawn and I could go out and shoot. So you just need to be very aware that the sun will still affect your photos even at night. The moon is going to be acting like a big globe of light that is going to blot out the stars, and you're not going to see the stars if there's bad weather. What gear do you need to shoot the Milky Way? Can you use an iPhone? Do you need a big, expensive full-frame SLR? Well, let me clear this up for you because this is a question I've had hundreds of times. No, you can't use an iPhone, and no, you don't need a full-frame SLR. Sure, it's nice to have and you'll probably get better results, but it's not essential. You could use an entry-level DSLR or a mirrorless camera, and you'll still get great results because the actual camera isn't anywhere near as important as the lens. The sensor is really good on this camera. It's a good quality camera and I'll get lower noise in my images, which is great when you do long exposures at high ISOs. But you can make a compromise and still use an entry-level DSLR. You'll still get great results. So that's something to consider. The camera, not that important. The lens, on the other hand, is quite important. So 2 things you need to look out for. Number 1 is a very wide aperture, or as wide as you can get really. And on this, I've got a 2.8. You might find that your kit lens comes with a 3.5. I've still seen people get good results with a 3.5 kit lens and a basic DSLR camera. But if you're interested in doing Milky Way photography on the long term, I would probably invest in a wide angle and wider aperture camera, lens rather, for example, the Rokinon 14mm f2.8. That means that you can allow lots of light into the camera by using a wider aperture. And because this is 14mm, I get a much wider field of view, and the movement in the stars is much less apparent when you have a wider angle because everything is so much smaller in comparison. If I zoomed in on the stars, within just a few seconds you're going to see movement. But when you're zoomed all the way out, you can shoot for 30 seconds, 35 seconds without seeing movement in the stars. So that's what you need to consider really. You don't need a full frame DSLR camera. It doesn't need to be that important. But you do want to start investing, if you're going to do this long term, you want to start investing in a wide angle lens. Wide angle, or rather ultra wide angle with a wide aperture. So this is a 14mm Rokinon with an f2.8. There, I believe Sigma does a 14mm f1.4 or an f1.8, which is remarkable. I might invest in that myself. And you could actually get half decent results with a 18mm 3.5. It just depends on what you're shooting and what compromises you're willing to make. When you're shooting with that, you'll have a shorter shutter speed and you'll have a higher ISO, but you'll still get to capture the Milky Way. So it's worth considering. That's the gear that you need. And obviously, this goes without saying, a tripod as well. That's more of an accessory than the actual camera gear, but you need to be able to hold your camera steady for very long exposures. So a tripod and some sort of remote or intervalometer to fire the exposure is very useful too. What camera settings do you use for photos of the Milky Way? Well, as you know, with all exposures, there's three different factors: the aperture, the shutter speed, and the ISO. And using my camera here, the 14mm f2.8 and a full frame camera, I'll show you how I set up my photos. So this is an f2.8 lens. That means at the widest aperture, I'm going to have an f2.8, and that is what I set my exposure to. Now, that might be a very shallow depth of field ordinarily, but we're focusing at infinity and we're going to have the stars off way in the distance, so we don't really need to think about the depth of field. What we do need to consider is how much light comes into the lens. And at f2.8, I'm going to have as much light as possible as I can get into the camera. You really need a wide aperture. So go for the widest aperture lens that you have while still looking for a very wide angle lens. So that's f2.8 for the aperture. Then we talk about the shutter speed. So you might think that for a photo of the Milky Way in basically pitch black darkness, you would want to have a really, really long shutter speed, and you do. But there's a certain cutoff point to this. And the reason for that is if you have a really long exposure, you'll start to see the stars in the sky start to move. And then that crystal clear, sharp photo of the Milky Way that you were capturing is no longer crystal clear. It's moving and it's just not sharp. So you want to avoid motion blur. And there's a very simple equation for this. You take the number 500, it's called the 500 rule, and you divide that by your focal length. So in this case, it's a 14. So I take 500, I divide it by 14, and that gives me about 35 seconds of exposure. That's how long I can take a photo before the stars start to appear as if they're moving in the sky. So I'm going to set my camera to a 30-second exposure. That way I know I'm going to get nice crystal clear photos of the stars. And then finally, the ISO. The ISO is going to have to be quite high for Milky Way photography. As I've mentioned already, it's pitch black. You hardly see anything when you're taking photos of the Milky Way. So with that in mind, you need to set a very high ISO. I would set my ISO on this camera to 3200. That is 32 times as sensitive as ISO 100, my base ISO. But yes, it will have a little bit of noise in the photos, but it means that I get a good exposure and nothing is too dark. I can start to see the details in the stars. And I can do a little bit of recovery later on in Lightroom or perhaps Photoshop if that's what you prefer. So let's go through that again. f2.8, 30 seconds, and then an ISO of 3200. That works perfectly. I use that basically every time I take photos of the Milky Way on this camera. That works perfectly on this camera, but if you're using a different camera, perhaps a crop sensor, well, some of the rules change. So maybe if you're shooting at 18mm, you can only shoot for 20 seconds before the Milky Way starts to move. And if you're shooting at 20 seconds, then you need a higher ISO, and the ISO might go up to 6400. So there's a compromise going on there. Because of the gear that you're using, you might have to compromise. But that's okay, that's photography. We're always compromising with our gear and our exposure settings. We can never just shoot maximum depth of field for the shortest possible shutter speed and the best image quality, the lowest ISO at all times. It doesn't work out like that. We're always compromising. So it's just something you need to consider. If you're using more basic beginner gear, you're going to have a higher ISO and probably a shorter shutter speed too. But for this camera, f2.8, 30 seconds, and an ISO of 3200. How can you tell if your photos are overexposed or underexposed when you take photos of the Milky Way? Well, there's one thing you can't do, and that's look at the LCD screen. Historically, it's been useless at telling you whether your photos are properly exposed or not because of the ambient light conditions, and the brightness of the screen will completely throw off your interpretation of the exposure. So you just can't use it. Instead, we use a feature that is often overlooked by photographers, and that's a histogram. Now, if you don't know what a histogram is, don't worry, it's not confusing. It is a mathematical representation of how well exposed your photo is. It's a rectangular graph that looks like this, and there is 256 columns in it, and the exposure of the photo is effectively mapped out across all of these columns depending on how bright or dark the pixels are. So starting all the way off in column 0 are pixels that have got 0 data in it, completely black. And all the way in up to column 255 are overexposed pixels, completely white. And then there's a scale of brightness all the way from bright over here down to very dark over here, and the pixels are mapped out throughout it. So a photo of the Milky Way at night is probably going to have a lot of dark pixels on the left-hand side, and then just a handful of very light pixels on the right-hand side. The aim is to not have any pixels in column 0 or column 255. That means that your photo isn't under or overexposed, and you can get a good exposure, and it's just a case then of moving it around afterwards in post-processing software, and you can adjust it and move the exposure around so you can see more detail. If you lose detail in the darkness or the brightness, you can't recover them, which is why we used a histogram to see mathematically whether your photos are over or underexposed. So we always use a histogram. That might sound a little bit complicated, but go ahead and take a photo, pull up the histogram on your camera, usually just press the info button, it will come up, and you'll be able to see, okay, well, I can see this is a dark photo, which is why there's lots of pixels over to the left. Or I can see it's a very bright photo, which is why there's lots of pixels over to the right. And that's how the histogram works. How do you focus when you take photos of the Milky Way? Because it's going to be too dark to use your autofocus. If you try and use autofocus, the autofocus is going to go out and in, trying to get a correct focus. And that's just not going to work. It's not going to find it. Unless you get a torch out and shine it on something, your camera is not going to be able to autofocus. So instead, we switch the focus to manual focus. And this is great because it allows you instead to just set the focus once, and then every time you go to take a photo, it's going to be in perfect focus. That is if you don't knock the lens or something. I always go back 3, 4, 5 times in a night and check that I've got the right focus. So that's something to bear in mind, but manual focus is going to be your best friend. And where do you focus? Well, the answer is simple. I use this for every single photo of the Milky Way, and that is at infinity. Infinity is the furthest distance you can effectively focus. That is where you're going to get the best details of the stars, because if you think about it, they are further away than man has ever even come close to being. So of course they are the furthest distance we could possibly focus. So you want to set your camera lens's focus to infinity. If you don't know what the infinity sign looks like, it's like a sideways 8 like this, and you'll find it on your camera's lens, no problem. Set your focus there for the best results. When you take long exposures with a high ISO, you tend to see a lot of grain in your images. That's that digital noise that makes the image quality look kind of subpar. But there is a way to mitigate some of this noise, and that is to use long exposure noise reduction. The way this works is, if I was to take a 30-second exposure with the shutter open of the stars, my camera would take a 30-second exposure, and then with long exposure noise reduction on, it would take another photo directly afterwards, but it would close the shutter. So it's effectively taking a photo of nothing. Then the camera will compare the image that you originally shot to this image of nothing. It will find out where the grainy, noisy parts are in the photo of nothing, and it will effectively undo it to the original photograph. So that is how you get better quality images using long exposure noise reduction. You don't need to worry quite so much about the noise in your photos if you use long exposure noise reduction. It's a really powerful tool and a tool that people often don't realize exists. I will say one thing though, it's a slow process. Suddenly, your already very long exposure photos at 30 seconds are taking twice as long, and it's going to drain your battery life even more. And if you're shooting something like a time lapse or you're doing a panorama and you're taking 6 or 7 photographs, that is going to be too long. 1 minute will be too long to capture a photo. So you can't always use it because you're going to see weird gaps in the stars and everything's moving between the photos. So instead of using that, I would just not bother with it at all. But when I am taking a nice artistic photo of the Milky Way, I will happily turn on long exposure noise reduction because I know I'm going to end up with better image quality. The last key to mesmerizing Milky Way photography is to process your photos. I'm going to walk you through processing a photograph I have here of the Milky Way. At the moment, you can see the details of the Milky Way, but with just a little bit of processing, we're going to have much better results. So the first thing I do is to turn on these warning triangles up here in Lightroom. That's going to show us if our photo is overexposed or underexposed. You can see when it's underexposed, all the black pixels turn blue, and overexposed, they turn red, which you can't see much of, but there's a few up here in the stars. That's just something that's important to watch out for. It's okay for a star to be completely white though. Then what I do is I open up the photo with bringing the highlights up, the shadows down, the whites up to about there. I bring in the clarity. Now, typically I would not push the clarity that far on a landscape photograph, but it's a Milky Way, so I can push this really high. I'm going to leave it around 60. The next thing I do is I scroll to the bottom. I would actually, first of all, go and turn on profile corrections, remove the chromatic aberration, select my lens from the drop down. We have a look here for the Rockinon 14mm. Then I'm going to put a small vignette on. And I'm going to use a healthy amount of dehaze. So I'm going to turn these triangles off just quickly so you can see this, but you'll see how powerful the dehaze is inside Lightroom. You see how much those stars jump out just by turning up the dehaze. Very useful tool. Now I'm going to leave this at about 30 just for now. Then I'm going to go back, I'm going to fix the white balance, going to make this slightly colder. So that looks about right. Then what I'm going to do is I'm going to grab a graduated filter from up here, and I'm going to drag it across the Milky Way like so. And I'm going to make a couple more adjustments just to this area up here. You can see the area that is being affected. I'm going to add a touch more clarity and a good amount of dehaze too. And in just a very short amount of time, a very quick edit, just to show you the basis of how this works, you can see that the Milky Way is looking better already. The next thing I'm going to do is probably just turn up the saturation on the purples to bring out some of the more purple details of the stars. And if I show you a before and after now, it's certainly clear which photo is more mesmerizing. That is a quick entry into how to shoot beautiful night sky photographs. But if you'd like to learn more about how to shoot the Milky Way, then check out all of the information below us on this page. I've released a whole course on Milky Way photography called Milky Way Mastery, and it's absolutely everything you'd ever want to know about shooting the night sky with the Milky Way. So go ahead and check it out below while you're still here. Thanks very much for watching.